Hey everybody, welcome to the Recoup. I'm Cooper Daniels, and I'm a guy that knows a little about a lot. And today I am here with Sebastien Guillemot. He is the co-founder and CTO of dcSpark, which is responsible for layer 2 solutions like Milkomeda and a wallet, a Flint wallet, I believe, on Cardano and some other things. So yeah, thank you for joining me, Sebastien.
Yeah, thanks for having me on. As you may have heard, we launched Milkomeda for Algorand just a few days ago, and launch has been going great. There's been no kind of known issues, so very smooth launch. Part of the reason it's smooth is because actually we secretly launched on mainnet a few weeks ago and just didn't tell anybody, just to make sure that there's no quirks, everything's really good. And then we did the public announcement, so surprise, we're live on mainnet. You can start using it. And we've had a few 100,000 come on board the layer 2 already, to start deploying the apps and trying out the protocol. And we've had really positive feedback so far from both users and developers.
That's awesome. So I heard you say Milkomeda. Is that the pronunciation?
Yeah, so the original way we come up with this name is there's two well-known galaxies, Milky Way, which is where we are, and then the Andromeda galaxy. And these are set to merge in a few billion years. And so we thought, we're taking, this EVM ecosystem and bring it to Algorand or bring it to other blockchains. And so we're kind of merging these, two large galaxies together. And so from that, we decided to take the milk from Milky Way and the part of Andromeda, Meta part. And so from that, the natural pronunciation would be Milkomeda. But the problem is that this is a one-syllable word and really hard for people to remember. And so I personally have been changing to Milkomeda since it has more stress on the syllables, and so it's easier to remember. But take your personal preference.
Got it. Milkomeda. I prefer Milkomeda. So there we go. I've been kind of joking about that on my channel because I keep on hearing everybody say it different ways. So I appreciate you saying it the way I like it. I like to say it. So there we go. Okay, I want to talk about Milkomeda a lot. And that's what we're mainly here to talk about. But before we do that, let's, if you don't mind, get to know you a little bit. I scrolled through your LinkedIn. I saw that you were a developer at Microsoft for a while, and then you made your way to Cardano. So if you could just give us a little bit of a backstory on you and how you ended up, at blockchain and cryptocurrency in general.
Yeah, for sure. So I was interested in blockchain for a while, but had never found any project that was particularly interesting. And when I say this, it's because if you look at the blockchain industry, even today, but even more so previously, a lot of projects come and disappear very fast. And so I did not want to, stake my career as somebody who was, fairly young at the time on a project that might just disappear and then there's kind of no value added. And so I kind of stayed on the sideline, following the technology or occasionally deploying stuff just on testnets for fun. And then I found Cardano, which was an interesting project for a few reasons. One of them is because just like Algorand, they were doing a lot of fundamental research and publishing like real cryptography and distributed systems research papers. And so I felt like if I joined this project, as a project where even if the project does not work out in the end, you never know, even if it doesn't work out, the research that the project did lives on and continues pushing the space forward. And, it's also part of the reason why I was also interested in Algorand and why Algorand is the second chain we're working with for Milkomeda. So we already deployed to Cardano as a side chain, and we deployed Algorand as a layer 2, which are different. I'm sure we'll get into the difference later on this video. But so that was kind of my transition. So I worked at Cardano for a few years at Emergo, which is one of the founding entities for Cardano, which is used to be based in Japan because Cardano started in Japan. And so that's why me, I'm personally based in Japan. And that's why you might have noticed that dcSpark, Milkomeda, and all our websites all have Japanese versions to it. That's kind of the history behind that.
Cool. So you were interested in cryptocurrency, but you saw a lot of it as a flash in the pan. And then when you kind of like zoned in on Cardano, you were like, wait, they're doing really interesting research. These people are trying to do something different. They're trying to take, some of the best things about Bitcoin and the best things about Ethereum, and they're trying to kind of merge those two things. and then you move on, and now so I saw that you guys are working with Solana, Cardano, and Algorand. Has the Solana project is not finished yet?
Yeah, so Solana is a project we're interested in working with. So the idea is that we want to bring EVM compatibility to non-EVM blockchains. Now,
Right.
we want to work with blockchains that have a lot of user attraction, are contributing a lot to the space in whatever way whatever way they prefer, and don't have native EVM support. And so Cardano was the first one we worked with as a sidechain because, as I mentioned, I had been working on Cardano for a very long time, so I was extremely familiar with how that chain worked. Algorand was the second because, as I mentioned, I really like the R&D agenda that the Algorand has and a lot of their amazing research work they've done. And then Solana has done a lot of amazing engineering work. I mean, they have some research stuff. I think a lot of what they've done is they've pushed a lot of like open source software and integrated a lot of really interesting technology on the back end. So they have a lot of strong engineers working on that team. So we're kind of interested in that, especially because Solana did not compete with Cardano in any ways. Two totally separate projects focusing on two totally separate markets. And so we thought that these were kind of two ecosystems, so we could contribute to it in one way or another. And of course, Solana doesn't have EVM either. And so these were kind of the projects that we're kind of looking into. So we prioritize Cardano and Algorand, and we'll probably get to Solana at some point. This is our current configuration.
Got it. Yeah, I mean, it's nice to hear. When the Algorand and the Cardano communities tend to look at Solana like, that's garbage or something like that. At the worst side of that. But it's cool to hear so you guys really respect the engineering and the engineers over at Solana, is what I'm hearing.
Yeah, I think part of the reason they've gotten so much adoption is because it's a fairly easy chain to work with and deploy with, and you can be upset about the way they've handled security of their chain, and I understand those critiques, but I think as a developer experience, from a developer experience perspective, there's a lot of interesting things going on that I think we can, and a lot of ecosystems have learned from what Solana is doing on the engineering front, and have adopted some of these into their own ecosystems.
Cool.
I'm not a big maximalist. Like there's not really any chain that I'm like, oh, these are the bad people doing bad things. As long as they're not a rug, usually there's at least some good ideas in there that we can take and inherit from.
Of course. And obviously Solana's doing something right. I mean, let's be honest. All right. So, okay, but moving away from that, we're not here to talk about Solana. We're here to talk about Milkomeda, which is just launched on Algorand. And it's a roll-up, like you said. And like you also said, the side chain that you did on Cardano. So maybe somebody out there doesn't really understand the difference between a roll-up and a side chain. So can you explain that?
Yeah, sure. I can kind of give you the overview pitch and then kind of get more into the weeds afterwards.
Sure.
So imagine you want to add EVM support to a blockchain that doesn't have EVM support. The way a lot of these projects have done it so far, historically, is through something called a sidechain. A sidechain is no different from a standalone blockchain. It's like I created a new blockchain out of nowhere and said, this is my new blockchain. The difference between a blockchain and a sidechain is purely philosophical. You say, sure, I'm my own blockchain, but I don't intend to be a standalone player. I don't intend to be a dominant layer one player. I intend to just attach myself to an existing ecosystem. So for example, for Cardano, we deployed Milkomeda C1, which is a sidechain for Cardano. And the way we are attaching to the Cardano ecosystem is, of course, there's a way to go between the two chains, but also Milkomeda C1 does not have its own token. And so it uses ADA as the base asset. So it's not trying to compete on the layer one kind of market cap. And so this is an example of a sidechain. And the nice thing about sidechains is that they have a lot of flexibility. Because they're basically their own standalone blockchain, you can have whatever consensus algorithm you want, whatever execution model you want, whatever parameters you want. And so Cardano, as you may know, is not a very fast protocol. So block times are about 20 seconds and finality is probabilistic. And so it can take quite a long time for blocks to be finalized. And so it's kind of like, I wouldn't say it's like Bitcoin level slow. Bitcoin's obviously in a whole separate league, but obviously it's a very different world from Algorand where you have, less than 4 seconds per block with instant finality. And so the fact that we're a sidechain allowed us to have faster block times and instant finality on the sidechain. So it's a different, kind of security trade-off as the Cardano main chain. And we can do that because we have the flexibility of the sidechain. So if you're wondering, like, if we can make it faster and cheaper, why not have everything in sidechains? And the problem is that it doesn't inherit from Cardano. So, for example, Algorand spent many years on a very ambitious research roadmap, right? They worked on this instant finality. They worked on this proof of stake system. They worked on the state proofs. They worked on all these, amazing, research agendas. And it'd be really unfortunate to say, like, okay, well, sure, we did all this great work, but let's just, put it aside and spin up this new, other blockchain, and that's where everybody will use what everybody will use for DeFi. It's kind of a waste of all the work that was put in, right? And so what we really want to do is we want to add EVM support while inheriting everything you love about Algorand. So it still uses algo, still, has the pure proof of stake, still has, access to governance, still has the state proof, still has, all the properties and love of Algorand, including, instant finality and so on. And the only really way to get that is through something called a layer 2. So if you're wondering, the definition of a layer 2 is a system that inherits the security properties of the base chain. So it's a vague definition, and the reason it's vague is because there's multiple ways to implement the layer 2s, many ways you can do it. So you might have heard of state channels. State channels are usually a layer 2 solution. And another kind of layer 2 solution that's really taken off is called rollups. So the key thing about rollups and why they're really taking off is people have realized that execution on layer 1 is really expensive. Right? It's really hard to have a global computer that settles all smart contracts for everybody across the world. What's much cheaper than execution is storage, right? Storage is relatively cheap nowadays, and building a decentralized storage network is much easier than building a decentralized computation network. And so instead of trying to run the EVM, instead of trying to run Solidity on Algorand directly, what we do is we instead store information about user actions. We say, like, user A wanted to do action B. They want to call the smart contract. And user B transferred money to user A. So we just take these actions and we basically create like a log file that says, like, this is what the users are doing. And then we post the data onto Algorand. And this is not execution data. It's just basically a summary of what users are doing. And then, so now that you have these summaries, the way you would synchronize the Milkomeda chain is you'd synchronize an Algorand full node with special software added to the node that looks for these data files, it looks for these logs. And whenever it sees these log files, it uses them to recreate locally on your machine some implicit EVM state. So the reason this inherits the finality of Algorand is because we still use Algorand for the data availability. No, you only have to synchronize the Algorand blockchain. There's no other like node you have to run, no other server you have to connect to. You're just doing Algorand and just Algorand. And also we use Algorand for the sequencing as well. Which, like, when you run a network, what's important is not only what is the data, what order is the data supposed to be executed in. And so we inherit that from Algorand as well through the fact that this data is all posted and sequenced onto the Algorand blockchain.
Got it. So when you're on, I have a couple of questions to unpack from that. But so when you're on Cardano as a side chain, where does since you inherit the security on, as a roll up, where does the security come on that side chain?
Yeah, so the side chain we have for Cardano is just the validator set. So it's just the proof of authority network with a rotating set of validators. So what we did for Cardano is we put out like messages in the community saying we're looking for people who are interested in helping us run the Milkomeda C1 sidechain. The requirements to join is that you have to prove that you're incentivized for the success of Cardano. So we had people running staples for Cardano join. We had people running businesses on Cardano join. And so we were looking for people who not only had the skills, but also were incentivized for the success of Cardano to pick them as the validator set. And of course, it's a multi-sig, so even if one validator is malicious, they can't control the network. And so we, tried to tackle this from a variety of different ways. But of course, it's, a standalone consensus, and you have to trust, that the C1 chain, the validators there are being honest, which is, the trade-off from the extra flexibility you get.
Of course. And my understanding of rollups has been that they've been primarily used to make Ethereum faster and cheaper, right? That's been as far as I really understood. And it's interesting because what you guys are doing on Algorand, I mean, you're not going to make Algorand probably much faster or cheap. I don't see how you could even make it much cheaper. It probably needs to be Algorand long term probably needs to get more expensive. Really, it could 20x. So once we start incentivizing relay nodes and all that, different conversation. But I guess my point is that this rollup is really for a completely different reason than rollups have been used for in the past, correct? I mean, this is to create an environment for Solidity developers and to also, I mean, to basically bridge in a lot of ways. It's almost more a bridge than it is what those traditional reasons. Am I thinking about this right?
Yeah. So one thing that we've noticed is that developers nowadays want to deploy their applications to as many chains as possible. So there's a lot, if you go to DeFi Llama and you check the top dApps at the moment, a lot of them are deployed to 5, 10, 15 different chains, and they don't care which chain they're deployed to. They just want to collect as many users to their protocol as possible, especially in the bear market. The more users they can get, the higher chance they have of surviving. And so these developers, especially in the bear market, don't have the time to rewrite their dApp for every blockchain. They can't go learn the SVM, AVM, and Plutus and all the different smart contract programming languages of the world. To run a lean business, they have to attract as many users for the lowest cost. And so a lot of these are looking for EVM compatible chains. And so we thought that probably there's a lot of benefit in adding EVM support to existing chains while inheriting the security properties of the base chains. Because we've noticed is that side chains are very hard to grow as like a part of your ecosystem. For example, Polygon is a side chain of Ethereum. And, when they created Polygon, it's like, oh yeah, Polygon's like, helping Ethereum out. It's like Ethereum, but, we have like a cheaper system. But it has always been like kind of like a friendly rivalry in the sense that like, oh yeah, sure, like Polygon's helping Ethereum. But at the same time, like they have their own stuff going on and projects are migrating from Ethereum to Polygon. And it always causes this kind of like slight tension. And, what we really, really wanted was to add EVM and make it feel native, make it feel part of Algorand, right? Still uses algo. There's no U token like Polygon. You'll be able to, inherit the security properties of layer 1. We're working on features so that you can access layer 1 state, contract state from the layer 2. And we're also adding functionality so that you can trigger smart contracts on the layer 2 from layer 1. So we're trying to make it as seamless as possible. And we think that's really the right approach because then any dApp that deploys to Milkomeda A1, the Algorand deployment, contributes to the TVL of Algorand. Any dApp that deploys to Algorand is increasing the number of users of Algorand, increasing the value of that community. And so we can really grow together. And so that's, I think, what crypto's all about. It's not about, building moats and trying to extract as much value from users as possible. It's about, having a system where we can all agree on a set of consensus and build an ecosystem together, and that's really what we want to do.
Yeah, we actually met each other briefly at Converge, and when I saw Vitalik speak there, he was talking about Arbitrum and whatever, and and he was talking about the scaling solutions, and it seemed like he didn't really, Polygon wasn't the first one out of his mouth. Let's just put it that way. So and
if I can add also to your question, and the interesting thing about what we're doing is that right now we're doing EVM for Algorand, but we can also use the same technology for Move VM for Algorand. So if you don't know Move VM, that's the one that's launched on Aptos and Sui, these two chains that are kind of have been in the news a lot recently. So if we wanted to bring these virtual machines to Algorand, we can do it through the same protocol. And then we could use the same protocol as well to launch to other blockchains in the future. So as I mentioned, Solana, if we ever end up working with them, we could launch EVM for them or Move for them. And then we could go to other blockchains as well who sometimes reach out to us asking for Milkomeda support and deploy these virtual machines over there. And I think this is all part of a trend in the blockchain space of decoupling consensus from the execution layer. Because if you think about it, what is the core value proposition of Algorand? What makes Algorand awesome? You could say we have this, nice virtual machine that you can use with PyTeal. But that's not really the core value proposition. When you go to developers and they ask you, why should I build an Algorand? Your answer is not oh, we have PyTeal and this is an amazing programming language.
Yeah.
Your answer is like, we have the instant finality and the cheap cost and the proof of stake system, decentralization. Like these are the core value propositions.
Mm-hmm.
And so if these are the core value propositions, you should be able to allow any virtual machine to run on top of it and just users choose whatever programming language they want. And so a lot of chains are realizing that their core value proposition is actually their consensus algorithms, and they want to take that core value proposition and have that available from as many execution environments and virtual machines as possible.
Yeah. And you said it, but I think it's worth repeating that, as a layer 2 solution, because you'll hear criticisms of layer 2s, like, why do we even need layer 2s, right? Like, why would Algorand need that? We can handle everything on the layer 1. And then all that does is encourage people to, throw their project on there just because they can. And then that layer 2 has their own token, and it doesn't really add anything to Algorand, right? Other than the fact that, okay, fine, it might get in the news more, but what you guys are doing is different. Like you said, Milk-Algo exists, and that is what's paying the transaction fees, and that's what's paying for what is the use case of Milk-Algo other than transaction fees? Or is that's basically it, right?
So Milk-Algo is, for those who don't know, it's the Milkomeda version of Algo, so it's like wrapped Algo. So basically, once you move to the layer 2, you're using Milk-Algo, and then you can at any time come back to the layer 1 and reclaim your equivalent number of tokens. So it's a one-to-one peg. And so right now it's used for transaction fees primarily. But we have other functionality that I alluded to earlier that's coming out that also have a certain transaction fee cost. So for example, we're working on a feature called wrapped smart contracts that allow you to call layer 2 contracts from the layer 1. The reason we're working on this is because we noticed that a lot of times when you're writing a dApp on Algorand, you might be okay with having the entire dApp run in Algorand. You have a PyTeal developer on your team. You know how to make everything work. You write all your dApp. And as you're writing this app, you're like, actually, like there's this one functionality of my dApp that I know already exists in Solidity. I know the contract. I just need this like one little thing. And I don't want to spend, thousands of dollars like getting my dev to re-implement it if I can just reuse some existing solution. And so I'd like to inherit just like this one part of my dApp in Solidity, and the rest is all, native to Algorand. And to allow this, we want to build this functionality called wrapped smart contracts, where from a user perspective, you're calling an Algorand smart contract, and then under the hood, it passes that message to Milkomeda, to the layer 2, runs the execution, takes the result and brings it back to layer 1. And from a user perspective, it's like you never even left Algorand. And so this will enable developers to better use their resources to get to market faster, cheaper, and grow their business better. And this functionality, of course, has extra computational requirements on the layer 2, and so all those will also drive transaction fees also paid in Milk-Algo. So we have a lot of other features we're adding on top of the base protocol that will also help accrue fees, which pay for the continued development and maintenance of the layer 2.
Got it. Okay, so just to recap for anybody out there, so the way a rollup really works is that in order to consolidate, is that you're not sending every transaction to layer 1. You're not sending every transaction to all. So they consolidate a bunch of transactions and then basically send batches of information. So if you wanted to check the sequence and you wanted to check the history of Milkomeda, you could, and then that keeps it cost effective and quick, right?
Yep, that's accurate.
Yeah. And then how does your layer 2, does that move as fast? Is it as fast as the layer 1 on Algorand, or is because of that kind of?
Yeah, so because we're primarily data driven, as I mentioned, we're not re-executing the transaction on layer 1, we're just posting the data to layer 1. Data is the primary bottleneck. So the question is, well, how much data can we post to the Algorand mainnet? And if we get 1 megabyte, how many transactions does that equate to? So the short answer is we get about 300 TPS equivalent on Algorand. But this is under the assumption that we get access to the full Algorand, block space. And obviously, as Algorand grows, there'll be more dApps, coming online, and everybody has to share block space. And at some point, I'm sure there'll become some kind of market around, who gets access to that block space. And so that will affect the TPS, but currently it's around that range, 300.
Got it. So that's helpful that you're also here now. You're the first, obviously. I mean, you're one of the first roll-ups outside of Ethereum, right? Are you the
Yep.
first?
Yeah, we're not quite the first. Somebody beat us by quite a large margin, but I think we'll quickly grow to become the largest by quite a large margin.
Mm-hmm.
So we're looking forward to that. The reason why is because most people are focusing on rollups, as you mentioned previously, for scalability.
Mm-hmm.
But we noticed that the same technology can be used for, basically plug and play virtual machines to add new virtual machines to existing chains.
Mm-hmm.
And, we're doing this for EVM. And as I mentioned earlier, we can do this to bring different virtual machines like Move VM or Fuel VM or these other virtual machines that you might know. But you
Mm-hmm.
can actually go one step further and use this to bring game engines as well. So there's another company called Pima Studios, for example, that's doing layer twos for gaming, that's
Mm-hmm.
bringing games to layer one blockchains as a layer two. And so there's actually quite a large spectrum of what you can do with this technology. So we're really at the beginning of what people can do with this technology, and we're trying our best to kind of pioneer that roadmap on this kind of unique subset of layer twos, which is for bringing new virtual machines to existing chains.
Cool. You mentioned it about data and storage, and I was in your literature, you said that you had to develop a novel data availability protocol from scratch. What does that mean?
Yeah, so I mean, there's a few different parts for it. So one of them is obviously, as you mentioned earlier, all the layer twos currently are for Ethereum, right?
Yeah.
So if you want to build a layer two for Ethereum, there's known steps, there's known GitHub repositories. You can just go to it, fork it, redeploy some new thing. It's a kind of a solved problem. But for Algorand, this doesn't exist yet, right?
Yeah.
So we had to, go in and learn the Algorand blockchain and, get developers to figure out the best way to make it work for Algorand. And so, in this sense, it's novel to the Algorand ecosystem. And then, once we eventually, write more about what we did, I'm sure other projects will come in and take the same ideas that we do. But we're kind of pioneering that front on the Algorand blockchain. But beyond that, we're also, trying to think about how we can leverage data availability for, different solutions as well. And so every rollup solution uses different techniques for how they work. So you might have heard like ZK rollup, optimistic rollups, and we have our
Mhm.
own rollup kind that also tries to use the, data availability in kind of unique ways to try and bring in some new functionality.
Cool. All right. So I noticed that upon launch, you guys you had a couple of projects launch with you. Blue Shift, which is a cross-chain DEX, and Seller Network, which I believe is a bridge, right? So
Yep.
what would the process be for somebody that maybe doesn't have all of a ton of experience doing something like this? What would they have to do, and what can they do really?
Yeah. So the cool thing about Milkomeda is that it works entirely entirely compatible with the EVM. So if you
Mhm.
have an existing if you have an existing DApp in Solidity, you can just deploy it as is. Usually no code change required. Hard hat still works. MetaMask still works. Foundry still works. All the tools you're used to will generally still work as is. So you can follow any tutorial you want for learning how to develop in Solidity and then get started. We have documentation at milkomeda.com, and you
Mhm.
can go there and follow the documentation. And we have all the RPC URLs, all the steps for getting started for A1. And so if you want, the specific instructions for A1, we have that there. But for just general development, any kind of Solidity tutorial will do. I will
Mhm.
add one slight caveat to that, which is that if you aren't familiar with Ethereum, one thing that's interesting about their ecosystem is that there are multiple implementations of Ethereum. So
Mhm.
it's different companies that have different versions of Ethereum, and they're all compatible with each other, but they're implemented in different ways. And some of these clients have client-specific functionality. That say, for example, like Geth only has this functionality, other uh, implementations don't. What they publish on chain is the same. What they do off chain may not be the same. And
Mhm.
so if your dApp depends on this kind of like implementation specific behavior, you may have to do some extra work. But this is only like a small subset of dApps, and if you like rigged up your dApp to depend on like some unstable specific API, like you usually know who you are.
Mhm.
So I just want to put that out there in case the dApp cares about this. But for 90% of users out there, they'll just be able to deploy their dApp as is, and everything should just work.
Got it. And then from just a user, investor kind of user of this, so what you would do is you would go to the Milkomeda app. You would wrap your algo basically into milk algo, and then you would be able to use something like Seller Network and send it across to a different environment basically.
Yeah, one thing I want to just make sure people are aware is that whenever you bridge tokens, like imagine you bridge your algo to Binance Chain, for example. You'll be able to do that, but there's no guarantee any DEX on Binance Chain will have any sufficient liquidity to actually do anything with these tokens. So if you want to bridge a token to any ecosystem or bridge any token to algo, be sure to check, which DEXs are available on which platforms and what liquidity they have for which tokens to make sure that there's actually, something to do with your token once you get to the other side.
Right. So there's some growing there to do. One of the best things that is happening right now with Milkomeda is the fact that this is creating an environment for all of these other dApps, that huge ecosystem EVM, to be able to bring that here. And then and then if it's on Milkomeda, there's going to be liquidity because that's going to be the whole project, really, right? That's what we're doing.
Yeah.
Right.
Yep. Yeah, I mean, we're going to be reaching out to, all the top Ethereum dApps and telling them, if you want access to Algorand, all the Algorand users, you can, come over and inherit the security of Algorand and inherit the fast finality, instant finality rather. And, I'm sure you'll love it. And that's our pitch to them. And we'll see how many people come on board with this journey. And, obviously the first people to come over will have the advantage. And the people who are chain maximalists and be like, I'm only on Ethereum and I'm not going out to other chains, they'll lose out on the users and their business will suffer.
That's right. And I have to imagine that using Algorand, being on top of Algorand, it's got to be kind of nice, that instant finality and 6,000 transactions per second and everything. That makes Milkomeda probably a better performant product.
Oh yeah, the TPS we can get as a layer 2 on Algorand is way higher than you can get as a TPS on any other chain, including Ethereum. The Milkomeda A1 runs faster than Ethereum base layer, runs faster than all the layer 2s on Ethereum as well. In fact, it goes faster than all of them combined. So the throughput we get from Algorand is really great, and the fact that you get instant finality is useful for a lot of use cases like gaming. Like one of the problems with Ethereum gaming is that the game state might get rolled back, which is like a really ugly user experience for them to have to like wait 10 seconds and then they make the next move and then, the chain rolled back, your previous move got undone, you got to redo it. Like this is not a great user experience. No. And so, there's a lot of, applications that maybe, like Ethereum, but, need a chain with instant finality and we can provide that through A1 thanks to Algorand.
Cool. And A1, does that stand for Algorand and it's the first one? So like if you did one with Move, it would be maybe A2?
Yes, that's a very clever naming scheme.
you guys knocked it out of the park. Yeah. Well, okay. So there is, my personal opinion is that Algorand and the Algorand community and the Cardano community, they have there's a friendly discourse between the two. It's like you mentioned, you're not a maximalist. You don't come off as a maximalist. I don't like to consider myself as a maximalist. I like to see what's good about either thing. But since you have such an intimate knowledge of Cardano, and now you're here and you've had to obviously look very deeply into Algorand, maybe you can just, for me, this is mainly for me, like what are some of your favorite things about both of these chains? Not that one has it and the other doesn't, but like what is something that like really impresses you about Cardano and what you love about in the tech? And then maybe, the flip side also on Algorand.
Yeah, I think that these projects, although similar in philosophy, have quite a few technical differences. One of the big ones is Cardano's the UTXO model and Algorand is accounting style. So I'm sure everybody on Algorand is familiar with how Algorand transactions work. So let me kind of go a bit into detail about how Cardano transactions work. So instead of saying like I am sending from my account to your account, it's more like physical cash. If you want to pay somebody, you say like, okay, here's my $10 coin and my 50 cents, and you get all these coins together and get, okay, I'm paying you $5. Here's my coins, and then give me back the change. And so Cardano works in this kind of UTXO system, and that's the name of this system that works like physical cash. And the interesting thing about this system is that it's really good for parallelization, because if you think about it, the state of a transaction can be represented just by knowing which coins you transfer to which person. There's no kind of global state that needs to be kept track of. And it means that writing any kind of software for Cardano is really simple, because oftentimes you don't need to know the state of the rest of the network. As long as you just know which coins came in and which coins came out, you can know the entire state of the transaction. So this is, really nice from like a optimization perspective, both for reducing the amount of times you have to query the network, reducing depending on global state, but also the fact that you're not dependent on global state also makes it easier to build like overlaid networks or ZK circuits, or these kinds of use cases. Because one of the biggest problems with, for example, the ZK EVM project, which is trying to rewrite the EVM in zero knowledge circuits, is that they have to like encode this global Ethereum state in this zero knowledge circuit, which is very difficult. For Cardano, most of these transactions only depend on like a very small subset of this local state you're interacting with. So it's actually very nice for this use case. And it's, in my opinion, part of a global trend of moving away from global states in blockchains. If you look at a lot of the blockchains that are coming out, they're kind of exciting. They're all about parallel transaction processing. And so there's some chains like Solana that still are a counting model, but put a lot of research into parallel transaction execution. There's other blockchains like Sui that are, trying to avoid this kind of global state as much as possible. And Fuel also tries to avoid global state as much as possible. There's quite a large move towards local state. And I think that's something that's interesting about Cardano, but also makes it significantly harder to work with.
Yeah.
So if you look at the developer ecosystem of Cardano, it's just such a harder problem to try and tackle compared to Algorand, where a lot of tools are much simpler, much more intuitive, and everything just works.
Right. Because that has been a criticism. I'm not like super knowledgeable about this, but it has been a criticism that the UTXO model is causing problems kind of scaling it, right? And making it quicker and making it an environment for lots of dApps to kind of build with. Is that true? I mean, it sounds like
So there's a few problems. One is, of course, the complexity goes way up. If you do this model, like the developers have to learn and figure out, and the user complexity is just way higher than you get for Algorand. So there's some of that. The other thing is that it's very hard to manage this concurrency properly. So like imagine you have an oracle, and this oracle is basically like a box that has data in it. And then occasionally you come in and say like, oh, here's the new data, put it inside the box. And anybody at any time can, come and look what's inside the box and see, okay, this is the data, and move on. So in the accounting style chain, this is very easy. You just have like a contract and just update the state of the contract whenever needed. And the UTXO model is awkward because, as mentioned, everything's represented by coins. So like if you want to update the oracle state, what you do is you give somebody the coin, the state gets updated, and then you get back a new coin, like just like you would with cash, right? If you want to change the serial number on your dollar bill, you go to like a bank teller and say like, can you give me an equivalent $5 bill? And they give you back a new $5 with a different serial number. And so that makes that like if the dollar bill switched, then all the dApps that were looking at the old serial number now can't find it anywhere because it like disappeared. And so managing this concurrency is very difficult. And a lot of projects try and manage this concurrency by adding global state in some way, shape, or form. So if you're interested, one of the projects I mentioned earlier in this video was Fuel VM, which is also UTXO based, but they also add some global state to handle this problem. So the problem is that the easiest way to solve this problem is adding some concept of global state in some way, shape, or form, which is the problem you're trying to get away from in the first place. So it's not an easy solution. You want your purity, but then if you have too much purity, then it becomes really hard to work with.
Got it. But at the very least, the Cardano community can call ADA a coin, not a token, right? That's pretty cool. Yeah.
Yeah.
And then on the other side, how about Algorand? What are your thoughts after you've now looked at Algorand and some of the strengths that you see over there, or some of the obstacles, really? Because you talked a little bit about the obstacle with the UTXO model.
Yeah, I think, it's kind of cliche, but maybe oversaid, but I really like the instant finality. There's a
Hmm.
lot of cases where instant finality is just like a requirement basically. And it's
Hmm.
nice you get it with Algorand. Of course, it comes with a trade-off, which is that Algorand's a BFT network instead of Nakamoto consensus. So it's definitely not a free trade-off. But for a lot of use cases, this is what you need. And it's great that we have a network that, has that. The other
Hmm.
thing is that, with Cardano, as you may know, it took a really long time to get their project out the door. For a lot of time, we were kind of in the research stage and not so much in the development stage. I would say at this point today, Cardano is more we have the research, now it's like the execution stage, not so much the research anymore. And so Cardano is definitely still working on interesting research and stuff in the pipeline.
Hmm.
But I feel like from what I've seen with the Algorand community, there's still a lot of research going on, and this is still kind of at the forefront, especially with the latest hard fork that was, adding in, state proofs and this interesting research. I think this is still, quite an active area of development. And
Hmm.
so that me as somebody who just loves the technology, it's really cool to be working with a chain that's working on these cool new toys that I get
Yeah.
to deep dive into and figure out how they work and how we can leverage this to build businesses. So that's been really fun as well. Part of the research, the reason Cardano is kind of in this um, execution stage instead of the research stage is because it's built as a monolithic blockchain. It's one
Hmm.
blockchain that handles the settlement and the consensus and the execution. It's one giant machine. And so when they release smart contracts, all the releases since that have all been about improving the smart contract execution language. And
Got it.
when all your developers, all your communities focused on improving the execution language, it means that there's very little like mental resource left to work on improving the core consensus. And so that
Hmm.
part kind of slows down, which is unfortunate. And that's why a lot of people have been trying to move towards splitting up consensus from the execution. In fact, ETH2 did this. There's now a different execution layer from the consensus layer. They split those into two. And,
Hmm.
that's kind of the same vision we're bringing with Milkomeda because, now we can bring these virtual machines to Algorand. We can improve virtual machines separate as a separate team, as a separate mechanism from the Algorand. And then the Algorand Inc. team can continue working on what they think is, the core value propositions of Algorand. And if people want to experiment on new execution models that might do something cool, instead of having to go to the Algorand Inc. team and telling them, hey, like stop working on this cool new consensus functionality. We need to experiment with this new programming language. They can instead just be
Yeah.
unblocked and start their own project without requiring the Algorand Inc. team for anything. And it really allows for tackling a lot more problems at the same time.
Yeah. I mentioned state proofs and I haven't actually asked you about them because when I think about what you guys have built, is it even necessary? Are state proofs even necessary in your ecosystem, like in what you're
Yeah,
doing?
so that's an interesting question. So to answer that, we need to figure out what are state proofs useful for, right? State
Right.
proofs are basically trying to summarize the Algorand state. That way, a network that doesn't have access to the Algorand state can somehow get a compact proof of the current state. That doesn't
Exactly.
really apply to us because for us, as I mentioned, to synchronize Milkomeda, you already synchronize the entire Algorand blockchain. So we
Yeah.
don't need a succinct version of the Algorand state because we have access to the full Algorand state. So from
Hmm.
this perspective, we don't need state proofs. We are very much interested in the underlying technology of state proofs. So state proofs rely on vector commitments, which you may know it's like a kind of new hot topic in cryptographic research. And there's a
Hmm.
lot of kind of really interesting use cases that are enabled by vector commitments. And so we're definitely looking into some of the same ideas and some of the work that the team did on state proofs and seeing how we can leverage this for a lot of the functionality we have planned for the future roadmap of Milkomeda.
Cool. And I'll let you go soon here, but maybe this is my last question. And I noticed on Twitter recently when you announced Milkomeda and going live on mainnet, I think Charles Hoskinson, he had a comment to you, and maybe you can explain his comment for me. Is that he's like, "Congratulations, but you didn't really." The gist of it was, "Congratulations, but you didn't do it the way I kind of wanted you to do it." What did he mean by that?
Yeah, so I mean, he was kind of saying that jokingly because, as every layer one wants, they want to be the winner, so to speak. And
Yeah.
so it'd be great if you could say like, oh, like Cardano is so good that Algorand is now like connected to Cardano.
Oh, right.
But
That's right. That was the other part of it that I forgot. Yeah. Yeah.
there's no connection between these two deployments. The Cardano deployments, the Cardano version, the Algorand version is the Algorand version, and you can bridge between the two. So you can go from Algo to A1 to C1 to Cardano. So you can go the full loop around if you want. But this is true with many other chains, right? You can also go from Algo to A1 to Ethereum to some other chains as well. So you can follow a lot of paths these days across various chains if you want. And so his comment is kind of being cheeky, saying like, oh yeah, like I guess indirectly because you can go from Algorand to Cardano, you could say that maybe Algorand is now part of Cardano, but obviously this is not quite how it works.
That's not quite true. And then, yeah, then other people responded, oh, now maybe Cardano is part of Algorand. And then it's just like, well, who's the daddy here is basically what we're all arguing about. Okay. Thank you. Hey, thank you so much for answering all these questions and, being a good sport about those types of questions. Is there anything else that I wanted to ask you about before we go? I think you made a good point earlier about, just for my audience, is that when you bridge to these other areas, like make sure that there's sufficient liquidity for you to do anything that you want to do, right? Because to end up on C1, right, on Cardano, you're going to have to somehow get your milk algo into milk ADA, right? Is essentially what you're going to want to do.
Yeah. That, or bring your like wrapped milk algo, either way you prefer, but there's no guarantee there's enough liquidity there.
Yeah. So, well, and then as people over there start to realize that there's people that want to do that, then liquidity can grow. That's the whole point, right?
Yeah. If there's an interest, businesses will come and fill that need.
Absolutely. All right, Sebastien, thank you so much for joining me. And is there anything else you wanted to add before we sign off?
No, thanks for having me on. It's been great connecting with the Algorand community. We've been building this for the past few months. Kind of in stealth mode. I don't want to say super stealth mode, but like, relatively, stealth. And it's been great to come out and announce and really, have everybody from the Algorand community welcome us. And we've had a lot of Twitter spaces and conversations and talks with projects and researchers and developers talking about how we can build this community together. And so it's just been amazing, getting to know everyone part of this community. And I look forward to interacting with all of you a lot more in the coming years.
Yeah, absolutely. And my last point is that, was this born out of the super grant that was announced at ETH Denver? I remember I was at ETH Denver and there was for EVM compatibility on interoperability on Algorand. So this is born from that drive, right?
Yeah. So we actually we're already working on the Algorand implementation, and we had a version for test. And so we went to the Algorand Foundation and said, hey, like, we're interested in super grant and we already have something on testnet. We're more than happy to receive the money to continue the work. And so they're happy to work with us on it. So it's been a great relation. I've loved working with the Algorand Foundation. It's just been an amazing experience. John Wood, Stacy, the rest of the team, they've been amazing.
Yeah. I'm sure you're familiar with John, right?
Yes.
You've met. Yeah, you know who John is.
Yes, I've had many conversations with him.
Yeah, cool. All right, man. Well, thank you. And then you're invited to come back anytime if there's ever anything that you would like to discuss and get out to the Algorand community.
Yeah, thanks for the invite.
Thanks, man.